So today I wanted to talk to you about bounds. Now the word bounds is just a shortened version of boundary. Okay, so if you had a house, you have a boundary which would be the wall of your garden around it or the fence of your house. Numbers are exactly the same. When we write numbers, for example, if we had 44, 45 and 46, each number has its own boundary and any numbers that fall within it are rounded to it. So for instance here it's 44.5 and 45.5 because both of those are halfway between the two each numbers. So 44 and 45, the halfway or midpoint is a technical term, is called 44.5, and 45 and 46, their midpoint is 45.5. So basically any number that falls between, that fits in this gap, so anything that's bigger than 45.5, sorry, that's the same size as 44.5 or bigger, or equal to or less than 45.5, you round to 45. Now, usually people write by accident 45.49 recurring, because you've been used to seeing every time that you write 0.5, you round up. Now in bounds, you don't do that. Because it's just a line, you just call it 45.5, and it's both the top of 45 and the bottom of 46, because 45.49 recurring is so close to 45.5, we call them the same thing. So here's the method, how to do it really. So if you have, for instance, say they gave you 107 and they said it was rounded to the nearest whole. Basically what that means is we might have had 107.4 or we might have had 107.5. They round, in this case, because we're working with bounds, to 107. But there also could have been numbers that were smaller than 107. So for instance, 106.9, 106.5. Notice that these also round. How you calculate that is quite easy once you kind of get your head around the idea that all numbers sit on a scale. So what I'm going to do first is I'm actually going to set up my scale. So if I'm counting in the nearest whole, what I'm going to do is start off with my number, which is 107, and then I'm going to write my next number, which will be 106, and that's just going to sit just here. And then I'm going to write my next number, which will be 108. Okay. Now, the midpoint between these two are where 106 stops rounding up to it and where 107 starts. So we need to find out the midpoint between these two. So the best way to find a midpoint, or the centre of two numbers, is to add them together and divide by how many there are, which is essentially a mean. So we're going to mean them. So 106 plus 107 is 213, and then I'm going to divide by 2, and that will tell me that my midpoint is 106.5. So this is called my lower bound, because if any numbers are 106.5 or more, we're going to round them to 107. Here, because we've got a difference of 0.5, and this is symmetrical, we're also going to have a difference of 0.5 this side. So this number will be 107.5 here. So our upper bound for 107 is 107.5. So if they just ask you for a lower bound or an upper bound, you can just state the number. How you'd write this as an error interval would be using inequality signs. So for instance, if we have 106.5 to 107.5, our number that we work with has to be greater than or equal to that, or less than or equal to 107.5. So as a mathematician, I know that if I see 106.5, I can round it up to 107, or if I see 107.5, I can round down. Now usually when you see 0.5, you always round up, but with bounds, because we assume that 107.49 recurring is much easier to write, sorry, I keep forgetting I haven't got as much screen. 107.49 recurring is easier to write as 107.5. We'll use that. So here's 45 to the nearest 5. I'm going to show you probably the most complicated one you'd see. So for example, if you have 45 and it's rounding to the nearest 5, that means we're going to count in 5s up and down. So 45 is our starting number. We're going to round up to 50 or round down to 40. Now we need to find the midpoint between each pair of numbers. So halfway between 40 and 45, if we add them up, we get 85. 85 divided by 2 is 42.5, and that'll be our lower bound. So any numbers that are higher or equal to 42.5 would sit either on this line or in here, so they always round to 45. And then here, because we've got a difference of 2.5, we've also got 47.5 here, because that's 2.5 this side and 2.5 that side. So now this is our upper bound. So our error interval would be 42.5 to 47.5. And if you're not sure about this equation, about these inequality signs, you can watch the inequality videos in the inequality playlist.